Hey guys, this is Lucas with a video on my algorithm for encrypting messages from letters to numbers. And these numbers are, well, as you can see now, the positions in the alphabet. So if you go for the letter A, it will be the position 1 and Z 26. So all in our alphabet, the Roman or Latin character or symbol or whatever you call that alphabet. So, well, I just want to go over this really quick, and I'm currently working on the decryption algorithm as well, which is more complex than this actually. And I will just, as I just said, go over this now to explain what I'm gonna do for my app that I'm working on. I call this app numcrypt, so num because of number, and crypt because of cryptic. And here you see are the two algorithms. Well, the decryption is not in here right now. That's in my playground in which I'm making this. And the app will look something like this. So here in the second control, you can just select what you want. I can actually run this really quick to show that. So here you see when I go over this decrypt, encrypt, and it just changes what you have here. Type something with numbers, type something with letters. Oops, I'm sorry. And let's close this down, and also this here, and I'm just gonna explain it now. So we have our function that I call letter to number, which accepts letters or words or what, which really accepts a letter. We actually can put in a string, but that won't happen. But it's meant to work for letters, and it will return a int as an optional because it may not be an int. We want it to be an int, but it can also be a null. So why null? Well, that can be because you may put in some characters it doesn't know, and then we have an error, and we don't want to have it crashing. So we will just say return a null, and it keeps on working. And then we just have all the cases here when we switch on the letter, so on our parameter. But actually, I don't know why I'm doing this. Anyways, here then down in the other function to number, we accept a word. So this is actually the normal, or that's the exact algorithm. We have a word of type string, and I will return a string. And at the end, you can see here we call our function, which will then in the app be whatever you type in the text field, and then you hit the return key, and it will call this function with your text field input. And then you see we get this here. So we always have a line in between the letters, or actually now numbers, and we have spaces as well. And I have to tell you that the decryption or decrypting or decrypt algorithm is much more complex than this, and I will have to figure out how to do this tomorrow. But I just wanted to go over this because I think it's a really, really interesting algorithm. So then what we do is we create a constant current word, and we create an array of, well, word characters. So when we have our parameter, we want all the characters that a word has. For example, hello, so H, E, double L, and O. And then we have an array that looks like this. Like that. So that's pretty cool. And then we have a result string that has nothing in there right now because we want to just return that then as our string. So now we have a for loop, yeah, that's right. We've got an I, so an index that we create, and then in 0 to word.characters.count. So characters.count means how many characters does a word have. So in case of hi, we have 1, 2, then a space, 3, 4, 5, 6, 7, 8, 9, 10. 10, well, characters. Okay, then we say if current word in with our index right now does not equal to a space, we say the letter right now is of type string, and then string, because we have to translate that. The string of current word with that index is our letter. And then we say result is result plus, because at the start we have nothing, so at the end it will just add that then. And then we say in here, letter to number, that's here we call our function. And we say letter to lowercase string. Why lowercase string? That's easy because we have lowercase letters here. And if we have uppercase letters, we will get a null, and we don't want that. So, and finally, we unwrap it because we have it as an optional type up here. And then if I does not equal to, so our index value, if that does not equal to word.characters.count -1, so because as we know, the first item is always 0, that's what we have to do, -1. But if it is not the last one, we want to put in a line, because if it's the last one and we have a line here, that line is pretty useless, and that's why we don't want that. And here, and current word I +1, so then the final, so if that's the last one, then if the exactly, if the last one does not equal to a space, then we want a line as well, because here in between we want our space. So that's pretty cool. So here you see that we have a space then, and if the current word and index +1, because then we want to check the next one. That's what I forgot to just say. If we have our current word and we go to the next one, so from the current one we are at, so let's say we are +1. For example, this is 2, then it checks if 3 does not equal to a space, because if we have a space here, we don't want to have a line before that. So now it makes sense. Sorry, I just forgot to explain it like that. And at the end, we just return our result, and that's about it. And we can put in actually everything that we really want to. There you go, that's pretty large. But you see, it has all our spaces, it has our lines, and it works. So yeah, you can try to understand this and maybe code it yourself. I think this is a really, really cool thing. In general, I like encrypting. It's a fun method, and especially decrypting is also pretty cool. So as soon as I'm done with the decrypting algorithm or whatever you want to call it, I'm gonna finish off the app and I'm gonna make a video about that. So thanks for watching, guys. So leave a like, subscribe if you haven't, leave a comment if you want to, and yeah, keep on learning. I'm out. Bye.